Alright guys, welcome to Conic Sections. A couple things that are important to know about conic sections. There are four types of curves known as conic sections or formed. They are parabolas, circles, ellipses, and hyperbolas. So in the next several videos, that's what we're actually going to discuss. Parabolas, circles, ellipses, and hyperbolas. Okay, so you've probably graphed circles and ellipses before, maybe in geometry. We've talked about parabolas, but we're actually going to graph them a different way and focus on a couple of different ideas with parabolas. Okay, these four types of graphs are formed when you really take a double cone and you take a plane and you intersect the two. And when you change the inclination of the plane, so for example, if we have this piece of paper and that's our plane, what they're talking about is if you slice something this way and maybe you come in at an angle this way or you come in at an angle this way at something, you change the pieces that you can cut out. And I've kind of given you an example here. Here's a double cone, and what we talked about is having a flat piece of plane that cuts the cone right here, which would give us an ellipse. Okay, so that's what we mean when we talk about what is a conic section. It's a double cone form, and we slice it with a plane, and we slice that different inclines, and we get different figures. And these four figures are circles, ellipses, hyperbolas, and parabolas. Okay, so that's how they're formed, and so that's what we're going to spend time discussing. In the next several examples, I'm just going to kind of show you an example of what three of these look like, and then later on we're going to get into more in depth with each type of graph. Okay, in problem number one, we're going to graph x squared plus y squared equals 25. We're going to want to know what the domain is and what the range is and the lines of symmetry. Now, from geometry, hopefully you may realize that this is an equation of a circle. Okay, there's no h and k value, they're both 0. So we're going to set the center at 0, 0. Now, if this is a little bit challenging, we're going to spend some more time on circles and in the equation of a circle, but this is a circle with center 0, 0, so we're going to mark that. How do you graph a function maybe you're not totally familiar with? Well, you set a table of values. And so I've done that, and I have 0. I've marked the first 4 points here in red because here's the idea. You have a circle at center 0, 0. Okay? You have 25 here. That's actually our radius squared. So 25 is 5 squared. So the radius is 5. From the center to the boundary is 5 units. So I get 4 points really free. Okay, 0, 5, 0, negative 5, 5, 0, and negative 5, 0. And I've plotted those. 0, 5, 0, negative 5, 5, 0, negative 5, 0. So those are my first 4 points. All based on the center, and I've gone out to the radius going north, south, basically east and west, if you think directions. So there's the radius of 5, radius of 5, radius of 5, radius of 5. That's really all the points I need if I wanted to graph a circle, but I can make it more accurate, the circle, by picking some other points. Now, I know my values for x shouldn't be larger than 5 or negative 5 because then I'd be outside the circle. That wouldn't be defined for the circle. So I picked 3 and 4, plus or minus 3, plus or minus 4. And I get, when I plug in 3 for x, I get, if I plug in, positive 3 or negative 3, I get plus or minus 4. So I go ahead and at 3, I plug in 4 and negative 4. At negative 3, I plug in 3, and negative 3, I plug in negative 4 as well. When I plug in positive 4, I get 3. When I plug in negative 4, I get negative 3. And so I go 4, 3, 4, negative 3. And same thing over here, and I connect my points with a smooth curve, and it ends up being a nice circle here. Okay, so what is the domain? Well, if you know where the center is and you know what your radius is, when we talked about going out 5 units and out 5 units, we got negative 5 and 5 between that. So that's where our domain is. X is between 5 and negative 5, which I got to make that little minus sign there. Okay, and same thing with the range. How far up and down are we going along the y-axis? Well, same thing. Negative 5 to 5, and so that's my domain. With a center, a radius at 0, every line through that center is going to be a line of symmetry because this is a circle. Okay? And so if you're having trouble on figuring out the values, how do I get all these values here, especially the 3 and 4, I'll show you later on after example 2. Okay, so problem number 2, graph 144 equals 9x squared plus 16y squared. Notice how the values are a bit different here, and this is actually an ellipse. Okay, an ellipse is similar to a circle, but the radius changes when you go vertically versus horizontally. So with the circle was 5, 5, 5, and 5. An ellipse, that changes. You know, you're going to have from wherever the center of the ellipse is to a boundary, horizontally will be the same, but it's going to be different than the radius from the center to the top or to the bottom. Okay, so that's, be very careful. We're going to graph this function, so we have to create a table of values. So really what you need to do is pick some x values and plug in. Okay, I think of 9 as being a perfect square, and 16 being a perfect square. So that's the reason why I kind of use -4, -3, 3, and 4 based on the numbers here. So you have to pick some x's. You may pick some x's that are undefined. And that's okay. It's going to be trial and error. And as we get along in this unit, you'll see that there's different ways that we can graph these ellipses and not have that problem of just guessing and checking. Okay. And so we're going to make a table of values. Here are the x values I chose, and here are the outputs. When I plug in -4 and 4, I actually get 0. When I plug in -3, I get plus or minus 2. 0 is plus or minus 3. 3, I get plus or minus 2. So in these tables, you're seeing, well, why are all these plus and minus answers, Mr. Bennett? Well, it has to do with the squares, okay? When you're solving for either of these variables, if I plug in an x and I've got to solve for y, I'm going to have to take the square root of both sides, and so we have plus or minus. Most of the time, like when you talked about Pythagorean theorem and you solved for your variable, you solved for c, let's say, you only had one answer. Well, you were talking about a distance, so we actually ignore the negative root. But there are two answers here when you take the square root, a plus and a minus root. Okay, so now I plot these points. I get 4, 0, -4, 0, 0, 3, 0, -3. Okay, and when I plug in -3, I get plus or minus 2. That's those 2 points. When I plug in 3, I get also plus or minus 2. Okay, and I connect the points with a smooth curve. And you can see the domain is from -4 to 4. The range is -3 to 3. Notice these values are different. That's how we know we have that ellipse there. So after this, let's just look at how I come up with a couple of these points, okay? So how do we get the points for these graphs? Well, you could use a graphing calculator, but you got to be careful. You got to solve the equation in terms of x, meaning you have to get y by itself. When we say in terms of x there, on this line, the equation has to be in terms of x. That means you have y equals something times x. Okay. Now, most of the TI-84s, 83s, you have to solve for y and then plug that equation in to graph. Okay. And then you can look at the table and pick off your values. However, mathematically, this is how we do it. So I plugged in -4 at first. So here's my equation. And in red, I plugged in -4 in for x. I'm picking that x. So what happens here is I have 144 equals 144, okay, plus 16y squared. So I subtract 144 from both sides, I get 0, and so I know I'm going to get 0 for my answer. Divide each side by 16, the square root of 0 is just 0, and that's how we have 0. Same thing will be if we plug in 4, okay? Now, I did one more example, 144 equals 9 times -3. I plugged in -3, and you notice how it's plus or minus 2. It's really not. It's really close to that answer, but we round it up. So if you subtract 81 from 144, you get 63. Okay, 9 times 9 is 81. Subtract 63. You divide each side by 16. You get something like 3.98. Or something very close to 4, and then when I take the square root of that number, I get plus or minus 1.98. Well, when you're graphing, 1.98, you're not really going to be able to do that, so why not just round up a little bit to 2, okay? And that's what we did here. So it should be plus or minus 1.98, but you know, graphing, you're not going to be able to graph that accurately. Just move it up to 2, and you can see it didn't hurt our graph. So again, that's how we got those values. You're still picking your x's, and you're finding y. When you have those squares on the y, you just have to be really careful. You're going to have 2 answers for one of these values that you plug in. So are these functions? No, circles and ellipses are not functions. They fail that vertical line test. And lastly, we're going to graph, we call this a hyperbola, okay? And so graph the hyperbola, state the domain and range, and the lines of symmetry, okay? And the lines of symmetry here are basically our reflection lines. It looks like the y and x axes if we reflect over, okay, same thing on both ends. Again, you create a table of values. So -5, -4, -3, and all of a sudden dot, 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 3, 4, 5. The dot, dot, dot means those, for me, those integers in between are undefined. You don't get an answer. You plug in 0 and you get something that does not work. Okay? And you can see if you actually plugged in 0, you'd have -y squared equals 9. Well, then you'd have y squared equals -9, undefined. You can't take the square root of a negative number. You can't get a real answer from that, okay? So when I plug in -5, -3, -4, -5, those are the 3 values that work, and 3, 4, and 5 work. These are the outputs that I get, basing on substitution and simplifying like I showed you in the last slide. So when I get these values, I actually plug this in. I'll plug them in and plot them. So you have -3, 0, 4, and 2.6, and -5 and 4, and then you have them plotted right below. Okay, the plus and minus, same thing here. So that's what a hyperbola looks like. All right, so this is kind of an introduction to conic sections. In the next 4 or 5 videos, we're actually going to specifically talk about different types. We're going to start with parabolas and then move into circles, ellipses, and finally talk about hyperbolas. So we're going to focus each video on a particular conic section. Remember, those conic sections are formed by slicing a cone, a double cone, a different way with a plane. Okay? Again, any questions or comments? Feel free to type them in below and I'll respond to them, or you can email me, or you can ask me in class. All right, so we'll see you next time, guys. Thanks for listening.